Multiplying binomials using the rectangle model, or also known as the box method. Lesson 8.5, you're watching this video with Ms.Y. Cavazos. So, rectangular model. Box method is easier and better to remember. Somehow it'll be catchier than rectangle model. Box method. One thing about the box method is you might have seen it in your biology class. So, you've seen how to multiply two binomials using this distributive method, using the FOIL method. Now you're going to learn how to use the box method. Now we have this problem here, and what I'm going to do is on the side over here, I'm going to show you both methods that you've learned so far, just so you understand that, hey, no matter what method I use, I still end up with the same expression, simplified expression. So let me go ahead and use the distributive properties, the first thing that we used, the first method that we used. So I'm going to simplify or multiply using that method. So this is how we arrange it. Then we distribute x times x, x squared. X times 4 is a positive 4x. 5 times x is a positive 5x. 5 times 4, positive 20. Then we look at this answer and we think, can we simplify? And yes, we can. So our final expression is x squared plus a 9x is what those two terms would give us if we combine them, plus 20. Okay, so that was one method. You also learned how to use the FOIL method. Now in FOIL, you got to remember F stands for first, so x times x, x squared. O stands for the outer terms, so x times 4 would be a positive 4x. Then we move on to the inner terms. 5 times x would give us a positive 5x. And then finally, we would have our last terms. 5 times 4 would give us a positive 20. And as you can see, these two expressions end up being the same. So of course, when we combine our like terms, 5 and 4 will give us a 9, thus ending with the same simplified expression. See? Identical. So now I'm going to show you how to use the box method. Box method. You're probably thinking, well, am I going to need a box method? A box? What does that mean? Box method. Here it is. So it's basically 4 rectangles kind of stacked together this way. You might have seen this, like I said, in your biology class. So what we're going to do is this binomial is going to go here on the side. So x is going to go here, plus 5 is going to go here. This other binomial is going to go up here. So x plus 4. Now I'm going to take you way back to when you did, you were introduced to finding the area of squares. They gave you a shape, squares, rectangles, whatever the case is. So let me make this look more like a rectangle. And they give you, okay, if this is 10 and this is 17, what's the area? So the answer usually went inside of the square. Well, in this case, we would have to multiply it 10 times 7, and that would give us 170. But again, notice where the answer goes. Inside the rectangle. Well, it's the same idea for this here. We're going to multiply in parts to fill in the area of each of these rectangles. So we begin with the first one. We're going to do 4x times x, and that area goes here. X squared. Next, it doesn't matter which way you go. We can do this times this, and that area goes in here. So 5 times x is a positive 5x. We move on to the next part. Again, we're trying to fill in the rectangles. So x times 4. Find the area, multiply, and that would give us a positive 4x. And then we have 5 times 4, and that area goes in this final rectangle, which that would give us a positive 20. What's so neat about this box method is that, as you can see diagonally, that's where your perfect squares are at. So I'm just going to write it all out. X squared, kind of like if I'm doing a z. So after that is 4x, and then 5x, and then plus 20. Like I said, we could tell where our like terms were at diagonally. So this would give us a 9x, bring down the x squared, and it's a positive 9x plus 20. And as you can see, ta-da, this matches that, and it matches this. They all give us the same simplified expression. Let's try it again. Box method. So we're going to have 2y plus 6 here on the side, and then y minus 3 here. Find the area. So I'm going to do this times this first. So 2y times y. That gives us 2y squared. Then we have 6 times this y, and that gives us a positive 6y. Then we have 2y times negative 3, and that gives us a negative 6y. And then we have this 6 times negative 3, and that is a negative 18. Again, if you notice, diagonally, there's your like terms. So that's 2y squared. 6y minus 6y, well, if we do the math, those will give us a 0y. They cancel each other out. And then minus 18. Of course, you will never find your answer written in such way. So the proper way to write our final answer is to not even include the 0y, because that term is long gone. So this is our simplified expression. Okay, so again, in case you missed a step of where did the 0y come from these two like terms, I went ahead and added them already, so I can just insert the answer right there. Let's try another one. Negative 4x plus 1 times 3x plus 9. Now, does this binomial always have to go here? No. What if I wanted 3x up here plus 9, negative 4x plus 1? You can do that. It is perfectly fine. So I'm going to multiply 3 times negative 4, which gives us negative 12. X times x, x squared. Next, I'm going to multiply 3x times 1. Well, 3x times 1 is just a positive 3x. We move on to the next. 9 times negative 4. That gives us a negative 36 with an x. And lastly, we have 9 times 1 gives us a positive 9. Again, what's so nice about the box method is that these are the like terms. You can see it right away. You can type it into a calculator right away. So that gives us negative 12 x squared. I combine these two, and I get a negative 33x with a plus 9. And then we have our simplified expression. Simple. Another example. Again, this example, you've seen it in the previous video, and you got to pay attention to that exponent because it means we have two copies of this specific binomial. So you got to write it twice. We're going to use the box method.